Okay, I think it's working. Okay, let's go over the quiz real quick. First one. Alkene, because it's got a double bond, right? Carbon-carbon double bond. Second one. Ketone. Yeah, that's yours. You can have that. Ketone. Carboxylic acid. And then we went over aldehyde right beforehand. That's the next one. And the last one is amine. So alkene, ketone, carboxylic acid, aldehyde, and amine. You guys have got to be great at memorizing, right?
The Swivl testing, they pretty much only focused on amine. Or no, what was it? Alkane. They pretty much were all alkane, and that was like it.
Right. But I assigned that table. Yeah. So the next one, 2,2-dimethyl-3-ethyl-butane. So is that a good name? So we got butane, and we have 2,2,3-ethyl. So what's wrong with 2,2-dimethyl-3-ethyl-butane? What's wrong with this name?
It's out of order alphabetically.
And it's out of order alphabetically. Okay.
Oh, I didn't even read that part.
Yeah, I didn't.
So we got to number it this way. So, no, we want to number it this way. Okay. So I got 2, 2, 3 trimethyl pentane. Okay, got that one. Next one is propanol. So 3 carbons. 3 carbons with a 2 isopropyl. Do you remember what an isopropyl is?
Yeah.
Ooh, look at that. You guys are so good. Okay, so what's wrong with 2 isopropyl 1 propanol? If I name it that way. A longer chain, right? So if I number this one, you always number this one the highest priority. 1, 2, 3, 4. So then we get 2, 3 dimethyl. Butanol. Okay. Okay. All right. All the isomers of butanol. All the isomers of butanol. I'll do them over here. So ROH is an alcohol, so we're going to have 1, 2, 3, 4 OH. Then I can put that OH there. What happens if I put the OH there? That's the same as that one, so that one doesn't work. Okay, so I can shorten up the chain and put the OH there. And then if I shorten up the chain and put the OH there, can I do that?
You already did that one.
Which one is that the same as?
The one to the left.
Ah, those two are now equal, so you can't do that one. Okay, so there's this one. 1, 2, 3, 4. Cross all. Okay. So then we're going to do ethers. So I've got diethyl ether. I've got methyl propyl ether. And now this propyl chain, I can I can branch to there. Anybody get another one?
Do you ruin the? I actually had that was my question in my head. Do you ruin the ether if you bind it to a hydrogen then? It's
Yes.
no longer a hydrogen.
Mm-hmm.
Okay, so it has to be to two carbons. It just has two R's, like two R groups. But does an R group, like if it's a certain like ones, it doesn't like it won't have like like I was confused by that too because I was like, so R always equals C then? Is there used?
I mean, our group is just a wild card, but in organic chemistry,
Organic. Okay, because in biology it doesn't necessarily. We don't necessarily know what the because we were talking before that the R group helps determine like what the amino acid is, and so I thought R group meant like it could be. I just didn't know. I was just asking. So.
like for an amino, it does mean it is a carbon for that though as well.
Okay, so
I'm pretty sure, unless there's an OH on there.
Because I thought they said it could change, and that's why it can affect like stuff like that as well.
Show me that later. But here, R is always carbon. So because a functional group is going to be, we want to identify what all the functional groups are. So if they're alcohols, we want to know what they are. R is always just going to be some chain. But I just put that there not to confuse you, but to help in case you didn't remember what an ether was, to help you. Because I did, yeah. All right, more questions? We good? All right. Look at that. Got your first organic quiz under your belt. You guys don't seem super happy, but... Okay. Chapter 2. Chapter 1 is really just kind of a review. Review of a lot of GChem. Chapter 2 is kind of review too. But so it's a lot of stuff that you've seen before, but we're going to hit it a little bit deeper than probably, I don't know how much they go into GChem into hybridized orbitals, but that's really important for us here. So chapter 2 is about bonding, is about how carbon makes all of its different structures, okay? So today I'm leaving early to go start the weekend early, so I won't be in my office hours today. Is that all right? Okay, thanks. But you can email me over the weekend if you want, and send me sapling screenshots, whatever you want to do. Okay, so you know about Lewis structures, right? You've done those like nobody's business. So, but we just a little review here. We want to remember that we're going to bring things in with a number of electrons. So these are the number of electrons, valence electrons for all these things, right? Okay, so hydrogen has 1 valence electron, carbon has 4, 5, 6, and 7, right? And that's where we're going to get our bonds, is that free electron is what's going to make our bond for us, okay? So we'll do something, just do something simple. We'll do carbon dioxide, okay? How do we do a Lewis structure? How do we start that off? Well, you got to know some things. Like you got to know, I mean, we can spend a lot of time like trying to go oxygen, oxygen, carbon, right? So we can try to bond up an oxygen to a carbon, and we could come up with some structures, but you kind of have to know that it's, some experience will tell you that it's oxygen, carbon, oxygen, okay? So if we take carbon, put it here in the middle, have our 4 electrons, we set our oxygen over here, got our electron there, okay? another oxygen over there. Being pretty basic here. Should be good with this, right? Then I can take and I can say, okay, I'm gonna do a little shorthand here, and I'm gonna take those two electrons and I'm gonna bond those together. And that every bond has two electrons. There's lots of rules for that. But you pair up those electrons and you get a bond. Okay. So let's just I'm just going to draw this again. Oxygen, carbon, oxygen, and I'm going to put our electrons out there. Okay, so I haven't lost any electrons, I haven't gained any electrons, and I'm just using the number of valence electrons that atom brought into it. Okay, so carbon brought in 4, I have those 4, oxygen brought in 6, I have those 6. You just can't, if you want to add an electron, you can. Electrons get added, but then you have to remember that you didn't, in that atom, I put, so in that atom, none of these are charged, right? I haven't done charge yet, but none of these are charged because I have the same number of protons as I have electrons in all of these, right? We good with that? I think I had a student one time that was really smart student, was just super confused about all of this, and he finally came to my office and just says, I'm just really confused. So we went over it again, and he's like, yeah, but I just don't see why something is charged or not charged. And I said, oh, we never talk about protons, but an atom is charged because it has one more or one less, or two more or two less electrons than protons. And you got to just remember that in your head, because we're not going to talk about that. We're just going to assume that that all the protons stay the same for all those atoms. Did I just confuse you more? Yeah? Okay. So nothing is charged at this point. So what's the next thing we need to do? What sort of rules do we have that we have to think about here? What do things like to have around them? How many electrons does everything like to have? 8, right? We need to fill an octet. So here I have 2 electrons. So if I look at this oxygen right here, I have 2 electrons here because we're sharing, 2 there, and 1 there. So that's not 8, that's 7, okay? And then if I do the same thing for, I look at this carbon right here, I have 2, 4, I have 6, so it doesn't have 8 either. So what are some things that we could do to help that out? And I've got, really simple, we could do a triple bond, possibly. Let's try a double bond. So let's combine those electrons there. Oops, that's a figure 8. And those electrons there, okay, I'm just going to combine those electrons. Let's see what happens. Okay, and I get a structure that looks like that because I now made another bond between each oxygen and carbon, right? Looks very simple. Now how many electrons do I have around that oxygen? 2, 4, 6, 8. And how many do I have around that carbon? 8. Okay. All right. So we fulfilled this rule that says that we want to fill the octet. We haven't added any electrons, so none of the charges have changed, and that's the structure of carbon dioxide, right? Okay. Why don't I have you do real quickly on your notes there, unless you already have my notes filled out. I'll draw it this way. Do CH3NO2. I made it look really easy. Nitromethane. Anybody know where you find nitromethane? Jason, where would you find nitromethane?
Nitrous for cars.
It's not nitrous, but they do put nitromethane in fuel for cars because it oxygenates the fuel, makes it burn hotter. Model airplanes do it a lot. Those little model airplanes. However you want to do them. Let's see what we got here. So we have a carbon. Let's see if you got this far. See, I wanted you to do it like I did that one there. We have 3 hydrogens. We have a nitrogen. And we have 2 oxygens. So how many different ways are there to put those together? Oh, probably a lot. So let's put it together this way. Let's put the 3 hydrogens there, okay? And leave one of these leave that one carbon there. All right? And let's make a methyl group. And then let's not worry about that anymore. Okay? So make a methyl group. How cool. You know what's really cool is that they have to stop next door because they're teaching computer science. I can keep teaching. I'm teaching chemistry. Those are battery operated, so you know where the exit is.
What is the beeping?
The fire alarm?
No, there's no generator.
What's beeping?
Unless they put one in. What's beeping? It's the alarms, sensors. The question is it here or is it everywhere?
It's in the library too.
It's probably everywhere.
Okay, we'll finish up nitromethane.
He's on his phone.
Okay, so I've got 1 electron there. You can all see, can't you? I'm going to take the nitrogen next. Okay, and then so I'm going to bond up that nitrogen, and then I'm going to take the oxygen. We'll do this kind of quick because we're a little distracted. And we're going to bond up, put an oxygen to each nitrogen, okay? And so let's just draw what I get here. Nitrogen, 2 electrons, oxygen, oxygen. Okay? All right, so, did I do that right? All right. So what's wrong with this structure?
The oxygens only have 7.
Okay, so carbon's okay, right? Carbon's okay. That nitrogen has 8 electrons, 2, 4, 6, 8. But the oxygens only have 7 electrons around them, right? 2, 4, 6, 7. Is that okay?
No,
Can't you make 2 double bonds from the end and get rid of 2 on the top?
Okay, you want to, okay. So it's not wrong to draw it this way. And it's not charged. Okay, it's not charged and it's not wrong. It's just if it can fill its octet, it's better, right? So we can bump electrons around wherever we want. All right. So let's take. Clock keeps running. Let's take, and you want to do a double bond to an oxygen. So how are we going to do that double bond?
Then you have to take the one off the side and
You want to take this one
yeah.
and dump it in, and take one of those and dump it in?
Yeah.
Okay, so then I have an electron left over there, right? And I have an oxygen here. Okay, I cannot have that.
The other one can have a double bond. Can you have another double bond?
Okay.
Why would another double bond make it worse?
Oops. So the idea. So you want to do this.
Yeah.
Okay. So this is what. So let me. This is a good point. How many electrons do I have around this nitrogen? 2, 4, 6, 8, 9, right? Cannot have 9. 8 is the max. You can have less. You can have fewer. You can be. This is okay. You can have fewer than 8. But once you get to 8, you've reached this part of the periodic table. You can't go one more. It doesn't happen. You can't. You can be less than 8, but you can't be more than 8. Okay? How many bonds do I have here? 2, 4, 6, 8. I got 10 electrons here, right? And then also, what was the number one rule that we had at the very beginning? How many bonds does nitrogen have? 3. I have more than 3, all right? So this is even more wronger. Okay? So let's go back. This is not a bad idea to come to here, but that electron can't be there. So let's take, now this is what's going to, electrons are little tiny balls of light, okay? We don't have any electrons right now. That's the problem. The electrons have stopped. But if I take, what I'm going to do, I'm going to be really tricky here. How many, so we can't have 9 electrons there. I just redrew the structure. And this one, this oxygen has 2, 4, 6. It's missing one, right? So I'm going to be really tricky here, and I'm going to move that electron to over here. I can do that. Electrons jump around, okay? So, have I fulfilled my octets now?
Yeah.
I have 2, 4, 6, 8, 2, 4, 6, 8. Oh, I got to get my other electrons up here. 2, 4, 6, 8, right? So I've fulfilled all my octets. But if I go back in and look at how many electrons nitrogen now has in its bonding pattern, it's only 4. And how many does it want? 5. So that means that nitrogen is a plus charge. Okay? And I look over here, how many electrons did oxygen have now? It has 2, 4, 6 plus that one there, 7. And how many does it want? 6. So oxygen is a minus charge. Is that okay?
Bonds for nitrogen not apply that?
Say that again?
We have 4 bonds around nitrogen now.
Oh. But we do have 4 bonds on nitrogen, but it's charged.
Okay. So when it's charged.
So when it's charged, so it's okay when it's okay when it's charged. Okay. The same is true for oxygen. We can have 3 bonds to oxygen. When do you ever see 3 bonds to oxygen? Hydronium ion, right? You put a drop of acid, put a drop of HCl in water, and you get hydronium ion. But you also have associated with that a chloride, right? That's going to counter it. This one is different in that this is not how it exists, by the way. I've just drawn it that way. How does it actually exist? I have a resonance structure here, right? And that's really not a good example of it either. It's somewhere in there. Those electrons are just all around that nitrogen and oxygen all together. Okay? But because it doesn't need a counter ion, its charge is internal. Okay? Now, that's just our rules, basically, to say it's nice to draw it with a full octet. Really what you'd need to do is do X-ray crystallography, and you can go in and look at these bond links and see where they're at. And they're in between a double and a single bond when you go and look at them. So it's in between. Okay. Any final thoughts? Chapter 2 homework is open.